Welcome to DSRT 734 class. This is statistics. These lectures cover the measures of regression and prediction intervals. Our main objective is to explain the three types of variations about a regression line. Also, we are going to find the coefficient of determination and also the standard error of the estimate for regression line. We're also going to learn how to construct and interpret a prediction interval for a y. So first we start with the variation about a regression line. In regression analysis, we have three types of variations about a regression line: the total variation, explained variation, and unexplained variations. Now, in order to find the total variations, we must calculate the total deviation. Now, if we remember descriptive statistics, we were talking about the process of calculating the variance. And in order to calculate the variance, first we calculate the total deviation or the deviation. The deviation will be each value minus the mean. That's each value of the data set minus the mean and the sum of all of them. So the same concept here. In order to find the total variations, we are going to find the total deviation, which will be the difference of each value and the mean. Then the square of it will be the total variations. And the same thing applies to the explained variations. In order to find the explained variations, we need to find the explained deviation. In order to find unexplained variations, we need to find the unexplained deviation. Then we square them. So a total deviation, again, will be the difference of each y value and the mean. Then we sum all together. Also, explained deviation will be the difference of the Now, y caret means the predicted y. Normally, the predicted y values will lie on the prediction line or the best fit line. So the difference of the predicted y value and the y mean. Unexplained deviation will be the difference of the actual value y and the predicted value y. So now to find the total variations, we square the total deviation. To find the explained variation, we square explained deviation. And to find the unexplained variations, we square unexplained deviation. So let's start with the total variation first. Here we say the total variation will be the sum of the squares of the differences between the y value of each ordered pair and the mean of y. So the formula of total variation will be the sum of the difference of the y value and the mean all square. Now with explained variation, it will be the sum of the squares of the difference between each predicted y value and the mean of y. So that will be the sum of the difference of the predicted y value and the y mean all square. And the same thing applies with unexplained variation. It will be again the sum of the squares of the differences between the y value or each y value and then each corresponding predicted value all square. Now, we also said the sum of the explained and unexplained variation also will give us the total variations. So total variations equal to explained variations plus unexplained variation. Next, we move to the coefficient of determination. Again, after the lectures, we are going to solve some problem and we will see examples soon. So coefficient of determination means the percentage or the proportion of the independent variable, let's say x, that determine the dependent variable y. So a coefficient of determination will be the percentage of the values of the x that determine or explain the value of y. Now to find it, we say it's the ratio of the explained variations to the total variation. We also can find the coefficient of determination by finding the PSC correlation value first. Then when we get the correlation value, which is the R value, we square it. So that's why we say the coefficient of determination is R squared. When we know the R value, we can square the R value, and that will give us coefficient of determination. Or we can use the formula if we know the explained variation and the total variation. Then it will be the ratio of explained variation divided by total variation. So now let's see example. Here we start with the coefficient of determination. The question here said that we have a correlation coefficient for the advertising expenses and the company sales data as calculated in our previous lectures. The R value was 0.913. Now, if we know the correlation coefficient, to find the coefficient of determination, as we said, we are going to square the R, or the correlation coefficient. Normally, we say the correlation coefficient will give us the strength or the degree of the association or relationship between the independent variable and dependent variable. Now, if R value is close to 1, in this case 0.913, we say we have a very strong increasing or positive relationship, which means when S increase, Y also increase. Always the R value will be between -1 to +1. When it's -1 or close to -1, we are going to say that we have a decreasing relationship, which means if S increase, Y would decrease. Increasing relationship is toward +1. If S increase, S is our independent variable. So that determines the dependent variable Y. Now with the coefficient of determination, we can only have values between 0 to 1 because we have to square R. So now if the value is close to 0, that will tell us that the percentage of the variables that determine independent variable, the X that determine Y, is 0, which means there's no relationship between the two variables. Now, if R squared is, let's say, 0.3, then we say 30% of the independent variable determine the dependent variable, or 30% of X values explain the Y value. So the question here says we should find the coefficient of determination. What does this tell you about the explained variation of the data, about the regression line, and also about the unexplained variation? So let's see. Now we have R already. So the best way to find coefficient of determination, which is R squared, we just square the value of R. So here we have 0.34. And this is, we can say that 83.4% of the variations in the company's sales can be explained by the variation in advertising expenditures. Now, when we subtract 100% from 83.4, we are going to say roughly 16.9, or let's say roughly 17 of the variation is unexplained. Now, next we move to the standard error of estimate. Now, a standard error of estimate is the standard deviation of the observed YI values about the predicted Y carat value for a given X value. So what we mean is that to find the standard error, it's more or less like finding the standard deviation. So that's why we say standard deviation of the observed Y values about the predicted Y value. So to be the difference of the actual Y value and the predicted Y value, each value. Y carat again means the predicted value. All square and the sum divided by the sample size minus 2. So now if the sample size is 10, then 10 minus 2. Now here we say the closer the observed Y values are to the predicted Y values, the smaller the standard error of the estimate will be, because there is the difference between the two. So if the standard error is 0, and this means the predicted Y value is the same as the actual Y value. And that's our main goal, to reduce the standard error of the regression. So how do we find the standard error of estimate? In worst, first we are going to make a table that will include the column heading shows. We have xi, actually the xi and yi will be the values given to us, the actual x and y values. And then we have to calculate the y predicted, which is the y carat. And that will be again, the difference of the actual y value and the predicted y value. We also have to find it. Then we square it, which will give us the variations. Then next, we are going to find the y carat mxi plus b. This is our regression equation. So use the regression equation to calculate the predicted y values. Now, after that, we can calculate the sum of squares of the difference between each observed y value and the corresponding predicted y value. So again, we calculate the sum of the squares of the differences between each observed y value and the corresponding y value. Then we find the standard error of the estimate. So the steps is almost like looking for the standard deviation. But of course, in order to find the y carat, we need to get our regression equation. Then when we get our regression equation, we substitute the s value in, and that gives us the y carat. Again, our previous lectures, we went through how to use the Excel to determine the regression equation and the best fit line. So let's say we have a question, and this was the previous example in our lectures when we are looking at the difference between advertising expenses and the revenue generated by a company. So here we said the regression equation for the advertising expenses and the company sales data as calculated in section 9.2 is giving us the following. So in this question, we were given the values of advertising expenses, and that's our X value for 10 years. And also we have a revenue generated for 10 years. So we have 10 values. So with these two, we can plot it in Excel and we can generate the regression equation and also the best fit line. So this is the equation we generated. In our previous lectures also, we explained how we can do this manually. So first we need to find, since we know the y carat is mx plus b, m is our slope, we have a formula to finding the slope. Then we find the b, which is our y-intercept. We plug in the two values, we have our regression equation. So if we have predicted value, in this case, the regression equation here, we can find the standard error of estimate. So we can either use the table to calculate the sum of the squares differences of each observed y value and also the corresponding predicted y value. Since we have 10 values, so this is our actual data for total expenses and the revenue generated. So we have 1, 2, 3, 4, 5, 6, 7, 8. Actually, it's 8 years. So if I know the X and Y, how do I find the Y carat, which is the Y predicted? I will plug in the formula, the X value. So first I'm going to plug 2.4, this 50.792 times 2.4 plus 104.061, and that will give me 225.81. We do the same thing for 1.6, plug it as an X value in the equation here. So 50.729 times the X value we have 1.6 plus 104.061, and that will give us 185.23. So after we get the Y carat, which is the predicted Y value, we find the difference of the actual value and the predicted value, and we square it. So when we square it and we sum everything, then that's what we call the sum difference square, sum square error. So we have it here, and this becomes what we call the unexplained variation. So after we know the unexplained variation, we can come here now plug it to find the standard error of estimate. Remember, the formula here is y, actual y minus predicted y all square. And this is the value here. And we know the formula is the difference of actual y and the predicted y all square and the sum. So that's the value we get from the table. N will be our sample size, which is 8. So we plug in the value. So this means the standard error will be 10.290. So the standard error of estimate of the company sales for a specific advertising expenses is about $10.29. Next, we talk about the prediction intervals. Now, if two variables have a bivariant normal distribution, and if for any fixed value of x, then the corresponding values of y are normally distributed. And also for any fixed values of y, then the corresponding x values also are normally distributed, as we can see in the diagram. So a prediction interval can be constructed for the true value of y. So given a linear equation, y caret equal to ms plus b, and we know the xo, that is a specific value of x, a C prediction interval for y is given as following. So y should be less than y caret plus e or greater than y caret minus e. So it will fall on this range, where again the e is given as following TC SE. Again, in the future, we're going to discuss about the concept of t values, etc. So here TC SE, square root of 1 plus 1 over n plus n, difference of SO and S bar square, divided by n again, the sum of S square minus S square sum. So the point estimate is y caret, and also the margin of error is E. Now, the probability that the prediction interval contains y is our C. So how do we construct a prediction interval for y for a specific value of x? So first thing we need to know is the degree of freedom, which is df, is n minus 2. So identify the number of ordered pairs in the data set n and the degree of freedom. Then second, we are going to use the regression equation and the given s value to find the point estimate, which is the y caret, predicted y. After that, we're going to use the table 5 in our textbook, Appendix B, which is again the t table, to find the critical value of TC, that correspond to the given level of confidence C. Again, we haven't covered this concept yet. When we start hypothesis testing, t-testing, we may discuss about this more detail. So we find the standard error of estimate, which is given to us, the formula here. And we find the margin of error E. Now we know the value of T, we know the standard error SE, so we can find the margin of error E, plug in all the values. X will also be given. Then we can find from the left to the right endpoint and form the prediction interval, which if we know E, the prediction interval will be the difference of y caret and the E, and also the sum of y caret and E. So the interval will be y should be less than y caret plus E by greater than y caret minus E. So let's solve this problem. Here they say we should, as we said earlier, in order to solve this problem, we have to know the confidence interval, and that will give us the value of alpha, and we know the degree of freedom, so we can use the t-table to solve this problem. So here they say we should construct 95% prediction interval for the company sales when advertising expenses is given as following. So that's the X value. And since it's 95% confidence interval, our alpha will be 5%. So first we find our y carat, because S is given to be 2100, which our data set is in thousands, so it will be 2.1. We plug in. We already know the slope. So we plug in the values and we get the answer. Also, y-intercept is given already. And this is the equation in our previous question. So we plug in to get our y carat. From there, we can look for the critical value. Degree of freedom is 6. So now we have to use our table, the T table, go through the row of 6, and then it's 95%. So our alpha will be 0.05 or 5%. The T value there will be 2.447 from the table. So if we know that, we plug in all the values, we can find the value of E, then we get the intervals. So the interval will be less than 237.449, and it should be greater than 183.735. So we say the y should be 183.735 to 237.44. This is 95% confidence, because remember, to find the critical value, the T value, we need to use degree of freedom. To find this TC, we need to use the degree of freedom of 6, and also 95% prediction interval. So we use the alpha level is 5%. So which means the result we get here, we say we are 95% confident that when advertising expenses are $2,100, the company will spend at least between $183,735 and $237,449. This is giving us some interval, some 95% confidence interval. In our previous regression analysis, we only find a specific one value. So for example, actually we did that already. Here we have the regression equation. We say we want to predict that if the company spent 2,100, what will be the income that they are going to generate, which is the y carat. It will be 210.592. That's it. That's what we know, approximate. But now we want to calculate 95% prediction. So this is where we have to have the concept of finding degree of freedom. We are using the T hypothesis testing concept. So we find the T critical value. And if we know this, we can find the E, which is the margin of error. Then the interval will be between the Y that we predicted minus the margin of error to the Y that we predicted plus the margin of error. So that will be the interval values. So again, we finished with these lectures. In these lectures, we explain the basic concept of the 3 types of variations about a regression line. We also learn how to find the coefficient of determination and explain what is coefficient of determination. We also find the standard error of the estimate for regression line. We shall go more detail on this topic when we cover the T-tables or hypothesis testing concept. So again, wish everybody the best. Thank you.